Oh, hi, my name is Colin Ginge. I'm from Retrotec, and today we're going to be talking about pressure in houses and the gauges that measure those pressures. Typically, houses lose energy in the pressure range from 0 to 5 pascals, and you're probably wondering, well, what is a pascal? Well, we'll be talking about that too. Those pressures are created by wind and stack and various forces that act on the house. And we'll also be talking about pressures in ducts that range from 25 pascals to 50 pascals. The gauges that we're going to be using to make those measurements look something like this, and we're going to make you familiar with those gauges so you understand that component completely. Over here we have a Minneapolis DG-700, a very popular gauge, and a Retrotec DM-2. And I want to show you the similarities and differences between the two. Certainly more differences than similarities. So the first thing you'll notice is both of them have two numbers in the display. This is channel A, channel B, channel A, channel B. Real simple. How that pressure is acquired is from, in this case, these two ports. This is the input port, so if we just press on this port, you'll notice that a pressure appears and the number is positive. If we press on this port, you'll notice that a pressure appears and the number is positive. Now the fact that I'm pressing on that port and a little bit of my fingers kind of squeezing into that hole is enough to actually create a pressure in this gauge. And exactly the same thing happens on this gauge, but the ports are back here. So what I'm going to do is I'm going to press on these ports and you're going to see the same kind of behavior. Exactly. So what we're looking at here is the difference in pressure between this port and this port. So if we have a positive pressure on this port and the same pressure on this port, we don't read anything at all because we're actually reading differential. If we have a positive pressure on this port, it'll read negative. You notice the negative sign over here. Same thing on this gauge. We press on these ports, which are the negative ports, we get negative pressures. So we're going to get a little bit more familiar with this positive and negative pressure business. So first thing I'm going to do is take a tube, and I put a green tube on the input here, and I'm going to blow in the tube. Now when we blow in the tube, we expect a positive pressure. So here I am blowing. And we have a positive value appearing. Now if I suck on the tube, we have a negative value appearing, which is exactly what we would expect. So positive, blowing, negative, sucking. Now, we got exactly the same thing going on over here, but what I've done is I've changed the units from pascals to inches of water. Now you can see that these are very, very convoluted units. There's 250 of these and one of those. So let's try the same thing. Positive, negative. So here we have a little mason jar full of water, and we've got a 1-inch mark marked on it. This gauge is set to inches of water column. So we're going to take this tube that's attached to the positive port over here, or the input port on channel A, and we're going to submerge it down in the water 1 inch. So this gauge is now reading 1 inch of water column. It's exactly what we'd expect. Now, just to show you what that looks like in pascals, we'll take the tube from the other gauge and we'll submerge it down the same 1 inch, and we're reading roughly 250 pascals, which is what an inch of water column is. Now there's a little bit of compression that occurs here because the water will actually flow up in the tube a little bit. So put it down another 1/16 of an inch or so, and we come up to almost exactly 250 pascals, which is the definition of an inch of water column.